net research, telecom testing, and network management excellence. Today, we will show you how RFC 6349 tests work on our new NetProbe 3000 analyzers. What is the RFC 6349 needed for? Standardized TCP throughput measurement. It provides a consistent, vendor-neutral method for measuring TCP performance, allowing for repeatable tests and comparable results across different networks and equipment. Verifying service level agreements, SLAs. Network providers use RFC 6349 to confirm that their managed IP networks can deliver the guaranteed bandwidth promised to business-class customers. Troubleshooting performance issues. The framework helps identify if network components like routers and switches or traffic policing mechanisms are degrading TCP performance, leading to poor application performance. Understanding network capacity. The testing methodology can be used to stress the network and determine its maximum capacity under high loads of concurrent TCP connections. Optimizing TCP parameters. The RFC guides the determination of key parameters, such as the optimal TCP window size and path MTU, which significantly influence TCP performance. Layered testing approach. Before TCP testing, RFC 6349 recommends running typical Layer 2 or 3 tests, like RFC 25, 44, to verify network integrity. How we do it? That's how it looks. Configuration of RFC 6349. Test point-to-point with NetProbe 3000 analyzers. To run the RFC 6349 test, first select the 1G button, then go to the next test page, and finally select the RFC 6349 button. A screen with test settings will open. First, you need to select the test run mode, server or client. If you select server mode, its IP address will be displayed on the screen. This address will be necessary to enter in the test settings for NetProbe, which you selected as the test client. In client mode, you will need to provide the server IP, the bottleneck bandwidth of your connection, and the duration of a single one-way test for the window sweep and throughput test duration of the test. Optionally, you can also specify the connection's RTT and MTU path. If these parameters are not provided, the program will calculate them automatically for the test. After starting client mode, a screen will appear on NetProbe with the status, progress, and test results. First, the devices are connected. Then the RTT and MTU parameters are calculated. And then the RFC 6349 test is run, divided into 2 parts: a window sweep test and a throughput test. The results of the window sweep test are available on the screen, available under the window sweep tab. This part of the test runs 4 separate tests for different BDP values. This test measures throughput in both directions for each BDP value. After completing this part of the test, the proper part of the test is started, the throughput test. Test results will be published after the test is completed, and during the test, you can access the charts screen. This screen shows the measured throughput values and the number of retransmissions for each second of the test. First, the test performed in one direction, and then the test performed in the other direction. After the test is complete, you can return to the summary screen, which displays all the RFCE 6349 test results. We will find there ideal versus actual throughput comparison. TCP efficiency represents the percentage of bytes that were not retransmitted. TCP transfer time ratio, which is simply the ratio between the measured TCP transfer time versus the ideal TCP transfer time. Buffer delay percentage, which represents the increase in RTT during a throughput test versus the inherent or baseline RTT. In this example, TCP efficiency was 100%, a perfect score. NetProbe 3000 offers an intuitive interface that allows quick start of measurements without unnecessary complexity. Its ultra-fast performance guarantees instant and precise test results, accelerating network diagnostics. Thank you for your attention. See you on our next video.